Hello everyone, my name is Jillian Wisinski, and this is my psychology project on the misinformation effect. So the misinformation effect is when false data is given, causing one to blend, alter, or create entirely new memories based on what they've been told. While psychologists do not know the exact reason why this happens, it was discovered that electrodermal signals change based on how important one thought question was. Your electrodermal signals are when you start to sweat, so your sweat glands and stuff, based like that. But there was no change in your autonomic responses or acute recall. Your autonomic responses is stuff like your heart rate, stuff you don't really control. You can't really, And acute recall is when you're given like a prompt or something to remember something, like you're kind of being cued to recall it, as the name would suggest. Um, you can't really avoid the misinformation effect, and you probably don't even know if it's been used on you. But there are ways in people who are more susceptible. So, for example, children who don't, think for themselves as much and maybe don't have the confidence in themselves will fall for it a bit more. When the memory is like a bit blurry, when it's maybe long term stuff, when you don't have as many details, it's easier to just fall for the misinformation because you just don't have all the information you need in the first place. Also easier to fall for it when it's coming from a trusted source, like your parents or something. Your memory is very fragile, so I want to compare the misinformation effect to the hindsight bias real quick. The hindsight bias is when people distort their memory to change the way they thought, felt, or did. It's also described as I knew it all along effect, and it's not as simple as amping up one story to make it more interesting or something, but in a manner that tricks the brain of that person to genuinely believe that's how they felt or how they thought. And the misinformation effect is when our memory is altered through misinformation. I say this because there's many things that alter our memory. It's not just the misinformation effect. There's also the presence of a weapon. If the memory is just kind of old and stuff, it's been a while and it's just we don't remember as well. There's also stuff like being different races than someone. So there's many different things that cause our memory to be inaccurate. So it's just important to remember that's not just the misinformation effect that changes how we remember something. So getting more in depth in the misinformation effect. So the person who's well known for studying this is Elizabeth Lotus, and she has a lot of advanced work in the misinformation effect. She studied at Stanford University, where she earned her PhD in psychology. And at Stanford, she was actually deemed the most likely to fail in her class, but she is well credited even being among the top 100 psychologists of the 20th century, according to the American Psychological Association. She has published over 20 books on her research along with 500 articles and is a professor. So in 1974, after graduating from Stanford, Elizabeth Lotus and John Palmer teamed up with the U.S. Department of Transportation to conduct what is known as the Lotus-Palmer car crash experiment. Originally, the experiment consisted of 45 college students, but in a later experiment, the number was amped up to 150 college students. In the experiment, the students were shown a video of a car crash and asked 5 questions. The questions were made to purposely distort memory. The most notable question was the one asking how fast the cars were going when they contacted, /hit, /bumped, /collide, /smashed into each other. The intentional changing of the verb changed how fast the students remember the car going. The different wording also impacted their long-term memory, which was studied a week after the video was shown. The results of this experiment was interesting to say the least. So everyone was shown the same video, but the answers varied very widely based on what verb was used when asked the question of how fast the cars were going. If they asked how fast they were going when the cars contacted, the average was 32 miles per hour. For hit, the average was 34 miles per hour. Bumped was 38 miles per hour. Collide was 39 miles per hour, and the average for smash was 41 miles per hour. And the verb didn't just change that one question, what they said in that one, they changed the rest of their answers. This was also shown during their long-term memory questions, which they were shown the video and then a week later they were tested on it again. And if they were originally asked how fast the cars were going when they smashed into each other, they were 2 times likely to say there was broken glass than the ones who were asked how fast the cars were going when they contact each other. And mind you, there was no broken glass, so when they were told smash, they remembered a more violent car crash and they kind of associated broken glass with that. So As I said earlier, Elizabeth Lowes, who studied the misinformation effect, did a lot of research on this, and there's so many more examples I could use from her work. These are just some more notable ones. So there was one where they kind of just changed the wording from A to the. So a participant was asked if they saw a broken headlight or if they saw the broken headlight. People who were asked if they saw the broken headlight were 2 times more likely to say that they did see a broken headlight compared to those who were asked if they saw a broken headlight. And mind you, again, there were no broken headlights. And another question, and it was more of a nonchalant thing, but they were in the video, they were asked how fast were cars going like when they passed a barn. And while testing, and some of them weren't told that there were a barn. It was kind of just a subtle addition of adding setting to their question. And in long-term memory, 17% of those asked a question with the additional like specifics of passing a barn saw a barn. So like 17% of people who were asked, who were told that in the question, but people who weren't told there was a barn in the background, only 3 of them said that they remembered a barn in their long term. So, and that's a 15% difference, which is, a lot. So I was very intrigued by this, and I created my own mock experiment, very similar to how the original one was done. So I have 15 different people and individually questioned them. So first I showed them a video of a car crash, and I asked them a few random questions, and kind of within the mix of the questions, I asked them that like speed question while changing the verb, and I recorded the answers and used the average when determining my findings. So the objective was to kind of just prove that misinformation effect is, very much true. It doesn't just affect college students from the 1900s. This is something that like affects everyone in modern days too. And comparing the data to actually kind of prove that this is real. And I did want to note that in the original experiment that Lewis and Palmer had many more students than I did. Even in their initial experiment, they had 45 students, and I only had 15. That's triple what I had. So I did my best, but yeah. And also, they had a constant variable of age. They had only college students. I had a wide variety because I didn't want to just have, I'm a teenager, have teenage friends. I didn't just want teenagers because of their lack of work experience, I guess. So my findings were when I asked how fast the cars were when they contacted each other, I was told 40 miles per hour, 38 miles per hour, and 35 miles per hour, which is an average of 37.6 miles per hour if I round it up to 38 miles per hour. And I have a note with what everyone said in the size, that's what I'm reading off of right now, but you can see the average on screen. For hit, I was told 40 miles per hour, 40 miles per hour, and 37 miles per hour for an average of 39 miles per hour. For bumped, everyone said 40 miles per hour. For collided, I was told 45 miles per hour, 40 miles per hour, and 45 miles per hour for an average of 43.3 miles per hour. And when I asked smashed, I was told 50 miles per hour, 45 miles per hour, and 45 miles per hour for an average of 46.6 miles per hour. And just like with the Lewis and Palmer side, there was 9 miles per hour difference between contact and smash. So that kind of shows that this can happen to anyone, and it's still very common. How does this impact us? Well, obviously this impairs our memory and affects what we remember and what we believe to be true. And this is especially harmful in courtroom settings. The difference from 9 miles per hour from 32 to 41 miles per hour makes a huge difference in a car crash case. Like I'm just saying, for example, let's say the road had a speed limit of 30 miles per hour. If I said that they were going at 32 miles per hour, that sounds a lot better than if I were saying they were going at 41 miles per hour. So that's a huge difference, and that could greatly impact the case. And lawyers and other people can exploit this to change answers and get them in the direction they want them to go. So this obviously you can use outside of a courtroom, but obviously this is really dramatic in a courtroom when it's like real life offenses and real life and stuff. So here are my citations. I used a lot of this stuff from my one book, Memory Lane, which was written by Jillian Murphy and Greene from Princeton University. So recommend reading that. But here you are. And finally, thank you for watching my presentation, and I hope you enjoyed it.